And we're live. Welcome everyone. Hopefully you've all had a great day, and we're going to be starting this virtual star party. Well, welcome to the virtual star party for the 12th of August. My name's Matt, and you will hear, just all of a sudden, you'll hear a disembodied voice of Roger Groom.
Hello everyone, yes, Roger Groom here.
So,
and sucker to help Matt with a cloudy night.
At least we can do this from, while it's still cloudy here in Perth, we've got your telescope in the central wheat belt, which we can use to at least show stuff in the southern hemisphere. So
that's right, and we were fully expecting it to be cloudy tonight. But just as I get online with Matt, I say, Matt, it's actually clear.
And we've been we're preparing for a cloudy night, and the central wheat belt decides to be nice and clear. So it's always interesting what the weather will throw up to you. So, guys, if you don't know what you've got yourselves into here, we're going to be showing you some cool stuff in the Southern Hemisphere from Perth in West Australia. Hopefully you'll love this, and you'll be able to tell your friends and family about what we're seeing, what you saw today, and if you can like the video and also subscribe to the page. You'll get notifications when we do this. We do this every fortnight on a Wednesday at 7:30, and so we'll be showing stuff throughout the year, and we'll show different stuff as well. So we have our winter sky that we're seeing at the moment, where we're looking into the center of the galaxy, and we've also got our summer sky, where we're looking out past the outside the galaxy, and we got some cool nebulas there as well. So, and being in the southern hemisphere, we've got all the cool stuff in to show you as well.
And what Matt's saying about the different times of the year applies to our public viewing nights at the Perth Observatory as well, which we're doing the winter ones at the moment, and got fantastic views of Jupiter and Saturn, which we actually had the gas giants astrophotography workshop last week.
Yes, I was really, really cold, and that's surprising coming from me who doesn't feel the cold. I was very, very cold, and I just wanted to go home as well. So
but we did have punters get some fantastic views of Jupiter and Saturn. It was actually a pretty good night for clarity. You can never tell with the planets, with viewing in general, what it's going to be on a night, and we actually scored pretty good for last Thursday night, and we photographed them. We got
the first part. We got the red spot as well on Jupiter, so that was always good to see as well.
That's true.
All right, so and guys, we are doing another astrophotography workshop. This actually in about 2 weeks' time, Monday and Tuesday, the 24th and 25th of August. Roger's going to be running it, and we'll be doing spring into Milky Way, considering that we're coming into spring, which is a really good time to take photos of the Milky Way. And so if you are interested, you can book through the website perthobservatory.com.au. We're also going to be doing a workshop up at Kalbarri as well, up in the northwest of West Australia as well. So check our website and also Facebook for those details, because I got the okay today. So I've just
awesome!
From DBCA, yeah. So I've now got to talk to the people up there to say yes, we do have permission to do it at the Skywalk there. So it's if you do book on that astrophotography workshop, you'll be one of the first few people to actually take astrophotography from that area as well.
And that's I think that's going to be Sunday 20th at Kalbarri that we're going to be there?
September, yeah, around that time. Yep.
Yeah, September. Yes, sorry. Yep.
Yep.
All right. Very good, Matt.
Unless there's another COVID problem or anything like that.
No. There won't be any of that.
What about bubonic plague or Ebola or something? All right, Roger. What are we seeing here tonight through one of your fantastic telescopes?
Yeah, well, surprisingly, we've got a reasonably good view of this here. Now, my mind's on blank, Matt. What are we looking at? The Prawn, wasn't it?
We're looking at the Prawn Nebula. Yeah.
Sorry. Yeah.
Yep.
And so I've just been fussing around with filters and things because this is the first time which this telescope's been seeing starlight since about 2 weeks or so, because we've had pretty much solid rain and cloud.
Yeah.
But luckily the focus was pretty much still spot on from 2 weeks ago, and I just tweaked that a little bit, and I've actually put this onto the hydrogen alpha filter. So this is the Prawn Nebula, which is up in the sort of central bulge area of the Milky Way. So right now, this is pretty much smack bang straight up.
Yeah, it's looking decent. It's got 7 minutes of light time here at the moment.
Yeah, that's right. Yeah, so what this is doing, this is a pretty casual way to do astrophotography. It's just a live feature of a piece of the software I use called DSkyX. And so I'm just, it's doing a live stack. So it takes a shot and it stacks that, joins that in with the previous shots. And it just keeps accumulating, a stack and accumulate kind of process. And so you can see that we're up to, as Matt said, 7 images. And it's just doing 60-second exposures. And we're getting reasonable detail there, I think, Matt.
Yeah, that's pretty cool. So sorry, go ahead.
I was just going to say that the brightness is a bit hard for me to judge. I've actually got YouTube playing on a different computer here to look at what's coming back, to hopefully judge the brightness for our viewers, because it's very different to what I'm seeing on my screen here. So hopefully everyone's seeing some nice peripheral sort of nebulosity up in this area up here, as well as the main bulge. There's also background nebulosity going through into the corner, bit of a dark lane through in this area, and we've got quite a nice star cluster over on the right here, which I have to admit I've got no idea what that star cluster there is called, but it looks like a nice tight little open cluster.
Yeah, so that would be part of the, actually we can actually show the people using Stellarium. So if we're coming here and we scroll in, I will just go into let me just get this done for you guys. Okay, so this is Stellarium right here. So we're looking, this is where we're looking tonight. So we're straight above and we zoom in, and here we've got the Prawn right here. So if we zoom in, that's part, actually it's called, it looks like it's, it could possibly be NGC 6240. No, it's not. It's called the False Comet Nebula. That's what it's called. So it's not actually part of the it's the nebula itself. So yeah. So this is a star nursery. So this is where all baby stars are being formed at the moment. And so this one's about 6,000 light years away from us, and it's about 240 light years across as well. So it's a decent sized nebula. And so what's happening here is there's bits of dust and gas that are clumping together, which to form stars. That's basically the really short answer of it. And this can be caused by stars getting passing by, or seismic waves going through the nebula and causing the dust particles and gas particles to come together. They start off really with static electricity. So when you get a balloon and you rub it on your hair, and as you pull the balloon away and your hair tries to stay with the balloon, that's the same thing that's causing the dust particles and gas particles to come together. And from there, it starts to get its own mass, and so the stars are able to, pull in a lot more gas and dust, and you get what's called a block globule. It's a cocoon where you've got the protostar in the center forming, and once the star's big enough and hot enough to cause nuclear fusion, that's when the star turns on, ignites, and blows away a lot of that material, and And that way, and what you have is the leftover is the star plus the planetary disk, which the planets will form from, or they can also form other stars. So think of this as a star nursery for stars. And you can see what Rogers just showed there was pointing that the False Comet cluster there, and that's the open star cluster. That's the next phase of a star's life.
Now I think something has made the telescope skip a little bit, so I've got some double stars coming out there now. So I might stop that series of exposures and find another object to look at. Just cool. I guess before we move on, I was starting before that false sort of problem frame came in. I was starting to see some really good ridges of sharp nebulosity along these sort of bow waves of the gas and so on accumulating there. But let's I'll stop this and I'll see if we can something else saying that.
Yeah, so while Roger's moving to the next target, so the Prawn Nebula was actually discovered by an American astronomer by the name of Edward Barnard around about the turn of the 20th century. So it's got a large number of very hot, very luminous young stars that are forming from the gas. And these stars include two large, hot blue-white stars. So these are very short-lived stars. They're fairly massive as well. So not enough for life to form. The really big stars, they kind of act like rock stars. They live hard, they die young. So where the little small stars, like the red dwarfs, they actually, they are very economical with their fuel, and they can take hundreds of, they think probably about 100 billion years for the first one to die. So it does, it's good that our sun is a middle of the road star, because it does give enough time for life to take hold. And also it's also good because it's active in the very beginning and active in the very at the very end, but it's got a good middle period where life can take a hold. A lot of the problems with the red dwarfs is that they can be flare stars. They send out a lot of solar flares, which can strip away atmospheres of planets that are very close, which have to be very close to them to be habitable, and they think they would be tidally locked as well. So they only show one side of the face to the star as well. So which is not great for life. You end up getting one side that could be basically cooked, and the other one that's perpetually at night. So it's not absolutely perfect concessions, but the thing with the universe, it always likes to throw up a curveball as well.
Matt, I see watching on my YouTube feed that I've got on this other computer, I've got someone there asking what Astro camera I'm using.
Ah, nice. Yep.
I'll just elaborate a little. This is a ZWO 1600 mm camera, so it's a cool astronomy camera, but a relatively entry-level one, I suppose. And it's got a filter wheel on it with eight positions, I think, if I remember right, 7 or 8. It's actually just photographing through a little refractor of mine. It's a 90mm William Optics Megres refractor, which it's photographing through. So the focal length is around about the 600mm focal length, because it's got a Borg DGL focal reducer on it. So about 600mm focal length with a ZWO 1600 camera on there.
Nice. And we were looking at the Prawn in alpha, hydrogen alpha, weren't we? So we were looking at...
Yeah, I should have elaborated on that. With those different filters in there, I chose to use the hydrogen alpha filter because just literally seconds before we went live, I did some luminance shots and they were accumulating nicely, but the stars started to really dominate too much. And I thought, well, let's knock the stars out a bit and just focus on the nebula. So I used hydrogen alpha for that last one. now we've moved on to Omega Centauri, and I thought that we would do Omega Centauri as a bit of a last hurrah to it because it's moving over into the west, and
we salute you.
Sorry, man.
We salute you.
That's it. Yeah, that's right. Goodbye, Omega Centauri, and hello, 47 Tuck is how it works.
Yeah.
So, in our viewing nights of the Perth Observatory, we're going to be moving on to 47 Tucanae instead of Omega Centauri for our favourite globular cluster now. And so why not for the astrophotography as well?
Yeah, and it's funny because you go, oh, you know, you just can't wait for that object to get, you know, say, Omega Centauri to get into the sky, you know, show it again.
Yeah, and then we're looking at goodbye.
Yeah, there's like goodbye. It's like, oh, and then you realise half the year's gone. So now, what?
This view of Omega Centauri is black and white because it is a mono camera, and I use the filters to make the view, which is why in this live view I can only do one filter at a time.
Yeah.
But it is a reasonably high megapixel camera, so I didn't actually think on the Prawn to zoom in at all. And this is probably going to highlight that I didn't focus very carefully, but that's still not a bad view of Omega Centauri's core there, actually.
Yeah, that's pretty good. That's amazing. That's one thing with 47 Tucana is that the core can get a little bit overexposed, where Omega Centauri does actually, you can actually see a lot of the core as well, especially in the astrophotography photos.
Yeah, so I don't know, Matt, if you want to elaborate a little on the details of globular cluster for us, and we'll let some frames accumulate on this.
Yeah, okay, guys. So we'll start off and show you exactly where Omega Centauri is if you haven't seen it before. It's the biggest globular cluster in the night sky. So we're actually going to be near the Southern Cross. So we're in the southwest at the moment. So we can turn actually on the imagery as well. So we have the Centaur, which is Chiron, the half horse, half man who teaches Achilles and Hercules and all the great heroes how to fight. Unfortunately, didn't tell Achilles about his Achilles tendon, which he's now famous for. And we've got the Southern Cross here as well. And this is actually the smallest of the constellations, the 88 modern constellations as well. And where we're looking is just at the at the Centaur's back, where his human side joins the horse side. And so we zoom in here. We've got Centaurus A galaxy, which we've shown on previous virtual star parties, and it's right there. It's quite noticeable, especially if you're in the Perth Hills, and especially if you go out to the country where there's not much light pollution. You can see it with the naked eye, and yeah, you can even see it in binoculars as well. And it's where you have an open star cluster, which is a bunch of really young stars. We're actually seeing a bunch of really old stars, and these big balls of stars are massive. And this one in particular is about 150 light years in diameter, and contains about 10 million stars, which they're tightly packed in a ball. And it's quite amazing because our nearest star is, star system to our sun is the Alpha Centauri system. Now, if you reduce the size of our stars, those stars, to billiard balls, and you have the sun in the CBD of Perth, the Alpha Centauri system would be as far as the Karratha, which is up the north of West Australia. So space is big, and you've got stars, especially in the centre there, which are about 10% of a light year. So we've never been able to find planets around in globular clusters, and that could just be because the stars, they're really old. They're about 12 billion years old, so they're generation 2 stars, which are mostly hydrogen and helium, and they do have a little bit of metals. So, and when we mean metals, we mean they are They have small amounts of, they have oxygen, nitrogen, carbon, that kind of stuff. So for astronomers, anything that's not hydrogen and helium is called a metal. So, so there might just not be the material there to form planets like carbon and that, which are building blocks for dust, and also for soil and rock and all that kind of stuff as well. So this one is the largest. Ooh, right.
What happened there?
Yeah, I can see your screen.
Which are we still on the remote one?
Yeah, we're still on. Okay. Yep. Rotor is saying, was Omega Centauri a captured galaxy? Well, potentially, it's. They think it could be a dwarf galaxy that has been gobbled up by our galaxy. Most of the theory is that these globular clusters are clouds of material that formed at the very beginning with our galaxy. They exist. There's about 120 of them officially that exist above and below the disk of our galaxy. So if you imagine you've got the disk, which we see side on, we see a whole lot of globular clusters down the bottom and above that disk, and some of them can actually travel through the galactical disk as well. And so the theory is with Omega Centauri that we could actually be looking at a core of a dwarf galaxy that's been captured by our galaxy and had all the outer layers stripped away, and what we're looking at is the core of the galaxy here. So it would be fairly interesting to if it is that case as well. So I hope that answers your question, Rhoda.
So we've got a good number of frames coming out here, and the tracking's holding nice and steady.
Yeah.
So we've ended up with a nice sharp view of that, which is pretty good. Now I thought about moving on to. I noticed that the southern Pinwheel galaxy is not too far away from this map.
Yeah, we could try that. Yeah.
We might try that. I thought, out of curiosity, we were talking about the filters before, and I thought I'll just throw this guy onto hydrogen alpha, which is not what you would normally use to photograph bright stars like this, like the Omega Centauri cluster. But let's just see what it looks like through hydrogen alpha, just for the heck of it.
Yeah.
Hydrogen alpha filters are really used for picking up those emissions from nebulas, and they do a good job of cutting out stars. So I'm expecting us to lose a lot of brightness, but it'll be interesting to see if any other detail comes out around it or anything like that. It is only a 30-second exposure, so let's see what happens.
Because when you're looking at nebulas, a lot of these will have reflective parts where actually there's a bit of it. Go. Yeah, you see a bit.
Do still see a bit, but wow, that really demonstrates the difference between the filters for our viewers. That, you've got to use the right filter for the right job, and you certainly wouldn't be wanting to use the hydrogen alpha for this unless you were focusing on specific spectrum of Omega Centauri.
Yeah. So there are two types. The most nebulas you'll find are reflective and emissions nebulas. There's also planetary nebulas, which are stars that, like our sun, that have come towards the end of its life, and they shed their outer layers out into space. There's also dark nebulas, which are nebulas, the dust and gas that have been backlit, and so we see them as dark ridges. So the Milky Way could be considered a little bit like that. But the main ones we see are reflective and emissions nebulas. And so reflective nebulas are where they are the stars that have been already formed are sending light and hitting the dust of that nebula, and that light's coming back to us. So you should see it as a bluish grey color with their own eyes. But once you start doing astrophotography, you'll see it as a bluish color. With emissions nebula, that's when you start to see the pinks, and that's a process that's very similar to neon signs. What's going on there? You've got radiation from the stars that have already been formed that are causing the gas to glow, particularly the hydrogen, and that's coming back as that pink color. So yeah. So
all right, so we've almost got the first image of the southern Pinwheel galaxy coming down here. The other objects which we've been looking at have been in our galaxy, so relatively close to us. Where this one is well outside of our galaxy. So let's see.
Wow!
We've
got a satellite. Those pesky satellites.
This gives you an idea of just how wide a field this is, because the southern Pinwheel is actually a decent sized galaxy as far as apparent visual size goes. But on this 90mm megares telescope, we've got quite a wide field of view there. Now that it's unfortunate we've got that satellite through there, but hey, what a perfect demonstration of how much of a pain in the ass
satellites are. And this is why you curse Elon Musk for Starlink, isn't it?
That's right. Luckily, I haven't actually been impacted by that yet. Just through chance, I haven't had them fly through the frame of my shots, I suppose.
I have actually. I have signed up to get notifications of when that's flying, when they're going to start providing wireless internet to the world. So.
Oh, right. Fair enough. Yeah. So we'll see how. Oh, there you go. There's a second one.
It could
as it moves through. Next one's gonna fit in nicely down here.
Yeah. So when you're looking at stuff through a telescope, we're actually looking at stuff back in time. So this is over 15 million light years away from us. So the light that's traveled all this way to get into the telescope, and so that we can show it to you, that's 15 million years old. So we're seeing it as it was back in the day. So not back yesterday, not back thousands of years ago. It's back 15 million years ago, and it's actually quite a small galaxy. It's 55,000 light years across, so about half the size of our galaxy. So,
and it's not offended by that, Matt.
Small.
It looks fantastic.
It does look fantastic. It does, yeah. And it's there's actually the French electronic band M83, which is actually named after this galaxy as well. So it's always good to
there you go.
Yeah.
It always surprises me how far south this Messier object is.
Yeah, it's quite interesting, and it's a little bit like you think it's a little bit close to the Centaurus A, but then you look at actually we can show you exactly where it is.
Actually do that, Matt. Well, this accumulates more because we've only got 3 frames so far.
So we're looking actually in Hydra. So as I'd like to take this time to say Hail Hydra. So no, we don't want MA. Oh, there it is. Yep. So it is fairly close. It's part of the subgroup of the Centaurus A and M83 galaxies. So just above, there it is. So that's what it looks like in color, right there.
Yeah, and of course we're only going to get luminance, which I'm photographing here tonight, unfortunately.
So there are some nice collection of some galaxies here as well, and it's in between the head of the Centaur and also Hydra as well, the snake as well. So, but it was actually noted by Charles Messier as one of his top 100 objects as well. So it's also considered to be a barred spiral galaxy as well. So it has a nice bar in the center there, and from there are the main arms, and then spurs of the arms come through there as well. So it's one of the nearest and one of the brightest star spirals in our night sky as well. So it's not great to see with the naked eye. Even through a telescope, it can be a little bit disappointing compared to Centaurus A, but where it does really come out and really impress people is through astrophotography.
And I'm still picking up on this, you calling it small, Matt. I'm reading on Wikipedia here, and it says M83 is a massive, grand design spiral galaxy. Thank you very much.
Yeah, but when you consider that
Milky Way.
Yeah, Milky Way is 110,000, and then you've got the Andromeda, which is was it nearly 200,000 light years across. It's look,
I get where you're coming from. And from an astrophotographer's perspective, this one is fantastic because it often fits well in chips. It fits well in my larger telescope, which this small one is piggybacked on the back of. But so I'm just zooming back out here to show the full field of view again, and that's what we've got there. And we've got a good few frames coming in there now.
Yeah.
So what are we up to? Actually, we're up to 6 frames.
And so this one was actually, even though Charles Messier added it to his Messier catalogue, which gives it its name, M83, it was actually discovered by Nicolas Louis Delarcaille in February 23rd, 1752, which is my birthday. except it was a couple of centuries before I was born. So, yes. Hey, that's
all right.
cool.
So I'll move on to the wild duck cluster.
Yeah, we'll do the wild duck cluster. Quack, quack, quack.
Oh, no, quick stop there before I did that. But anyway, let's see. Wild duck. So, yeah, the open clusters in the first shot were looking quite fantastic. So I thought, well, let's see what some other open clusters look like. Now I'm just going to zoom out a little bit here to check where I'm looking.
Cool.
So fairly high in the north, altitude 56 degrees there. So let's slew the telescope round to that. If I look straight up while you're watching my screen here, you might see the telescope is that yellow dot, and you can see that it's moving through, doing a meridian flip from the western side of the sky across the south, and it's going to come into the north here. It's on a German equatorial mount, and those mounts you have to do what we call a meridian flip to rotate the OTA around to get onto the other side of the sky.
Yep. And while they're there, I'll just show them exactly where it is in the night sky. So we'll come back to Stellarium, and it's the 11th of Charles Messier's objects. So we're coming into the constellation Scotum, which is the shield next to Ophiuchus and also Sagittarius, and it's right here, the wild duck. So
I'm just taking the first exposure now. I'm just doing 30-second exposures to start with. We'll see. That probably will be enough for this.
And we're doing this cluster because ducks fly together.
Matt, I was just thinking with the astrophotography workshops, the Monday and Tuesday coming up in next week, I think it is. Are they sold out? Or
we still got spots. Yeah, we've still got spots available. Yeah.
Okay, that's good. Yeah. They are small group workshops, and people bring along their digital SLR or mirrorless camera or such. And this one is focused very much on wide field. So we have a night. Monday night teaching you how to take the photos, and Tuesday night actually taking the photos. And of course, if the weather messes us around, we'll switch nights or mix it up as required. But that's Monday and Tuesday.
Yeah. So hopefully you're all.
And actually, it's not the 17th, 18th, is it? It's the 24th and 25th. Monday and Tuesday.
Yeah.
24th, 25th, and that's
so excited to. You're so excited to get to do another.
Of course. So we got some frames coming in here now. That looks reasonable actually. 30 seconds. We've got some nice a nice star field, very nice star field with the dusty sort of dark areas through the background. A couple of nice bright stars down here, and the wild duck cluster in the middle there.
Yeah, and so this was discovered by Godfrey Kirch in 1681. So it's amazing. It's amazing to it'd be an amazing time around that time, looking at objects that most people had never seen before.
Or at least not catalogued.
Yeah. So that the name the flying duck comes from the triangle, the formation of the triangle there, and he thought it looked like a flying flock of ducks as well. So obviously this is the or it looks like from the Mighty Ducks movies, the Flying V. So you never seen the Mighty Ducks movies?
Look, I did as a kid, but I have to admit I've forgotten.
Quack, 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 Mr. Ducksworth. I hope the people that be watching will be catching my Mighty Ducks references there as well. So
yeah, I hope they appreciate it more than me, sorry, Matt.
So yeah, it's one of the most richest and most compact of the known open clusters as well. So they think the age is roughly around about 360 million years old. So think of them as like teenagers really for stars. Open star clusters, they go anywhere between toddlers to university students in terms of age of stars, and so it's about about 190 light years across in its diameter as well. So it's a decent size cluster, and it's about 11,000 light years away from us. So
11. So that's interesting. The 11,000 light years. So
actually, no. Sorry. So that I made a mistake there. That's the solar masses. That's how much it weighs. No. It's about 6,000, just over 6,000 light years away from
6,000. Okay. So 6,000 light years versus what the 14.7 I think million light years of M83.
Yeah, it's definitely a lot closer. Yeah.
Yeah, that's right. So this is of course back in our galaxy as opposed to M83, which was way far away outside of that galaxy. Yeah,
this is a hop, skip, and a jump compared to the mega journey that would be going to M83 as well. So
yep.
And it's, now the cluster is actually fairly metal rich as well. It's got an abundance of iron, despite its youth. So this is possibly due to the Perth molecular cloud done by a Type 2 supernova. So a Type 2 supernova is a massive big star that's just blowing itself to bits as well. So that could be why there's a lot of iron in there. And from that nebula that formed from the explosion of the supernova, these stars have been formed as well. So there's at least 9 variable stars which they change their brightness as well, and there's also 2 eclipsing binary star systems as well. So it's a pretty interesting star cluster.
Got a lot going on there.
Yeah, there's a lot going on there. It's all happening.
I noticed that I've got a little bit of trailing in this shot now, and I think that's because I've completely meridian flipped and switched from southern hemisphere to northern hemisphere of the sky as well. Yeah. And so what's happening is that the Megrez, which is piggybacked on the back of my large telescope, there's a slight bit of slop in the sort of flexure in the mounting of that, and it's slowly settling down into position. It's probably actually the draw tube of the Megrez, possibly, because I know that's got a little bit of play in it. The other thing which I was just thinking of, which has completely escaped my brain. Oh well. I was actually wondering if after this one I might try another galaxy
Yeah.
for us, Matt. I've never
There's
looked at these galaxies, so it's a bit of a gamble.
yeah. There's one. There is one in Pavo, NGC 6744. You can go to.
Okay.
That actually is funny because I was looking a couple of weeks ago at different galaxies we could look at, and I went, oh, there's this one in Pavo, and then all of a sudden I started seeing it in Astro Bin, and then I think there was even one on Astronomy Picture of the Day before it's Comet Neowise decided to go naked eye and take up at the page as well. So. So Mel's is asking, is this at the observatory or online? So we're actually, we're using Roger's telescope up in the wheat belt. So if you guys watched the May 23rd virtual star party where we had celebration of the intrastate borders being reopened, we went out to Roger's property for a big party, and while other people were enjoying themselves a little bit, probably a little bit more than we expected, Roger and I stayed back and showed the night sky before the clouds rolled in. So we're doing this technically online because Roger's having to log into his telescope there, and we're looking at it through Roger's desktop there at home. Oh, the workshop. The workshop is actually at the observatory. So yes,
should have clarified that. Yes. Up at the Perth Observatory in Bickley. We should be very specific on that, Matt, because we still occasionally have visitors turn up at the wrong observatory.
Yes, in the Perth Hills. So yeah. So if you're heading north and you're going the wrong way from past Perth.
Right, so I'm just going to take some shots of this NGC 6744, Matt.
Okay, so I will then show...
8. It's a countdown. 7.
Okay, hopefully we're back. Sorry guys, hopefully you can see us now. Sorry, we had our open broadcast software just froze. So hopefully we're still with you. Oh, we got people coming back. Sorry about that.
Matt was madly clicking around to save the OBS studio software while I'm counting down. Matt, we've got 12. We've got 10 people left. Matt, we've got 7.
It was funny because some of people might know I'm a big fan of Formula One, and 2 weeks ago they had the British Grand Prix, and Lewis Hamilton's tyre blew on the last lap, and he had to do the whole lap. No, it actually blew on the halfway through the second last lap. So he did the half of the second lap plus the last lap with the tyre, front left blow on tyre, and his team engineer was going, Lewis, you've got 30 seconds, 20 seconds, 10 seconds. This is the gap that he built up to Max Verstappen. And here I'm going, just please does that tyre go, because if his tyre goes, then it means Daniel Ricciardo gets into third place. But it felt like that. I was pressuring. I was coming, going, come on, yo. So it's coming up nicely there.
It's coming up okay. It is a fainter one. So this is still a reasonably bright galaxy, but compared to M83 we had earlier, it is coming up quite a bit fainter.
Yeah, so this is an intermediate spiral galaxy that we're having a look here. So instead of being 15 million light years away that the M83 was, this is about 30 million light years away. So it's even further away, and it's also another. They consider this as a Milky Way mimic as well. So this is yeah, they think this is what it looks like. Our Milky Way would look like. So you can see there's a bar in the center there. It actually lies within the Virgo supercluster. So when you look at the night sky, it's coming through really nicely there.
Okay.
Yeah.
It's a little bit on the fuzzy side, but not.
It's only going to get better. Yeah.
Yeah. Okay.
And so when you have a look at the universe, it looks a little bit like spider webs. And you get these little knots where we call basically superclusters. And so there's something like a couple of thousand galaxies.
Spider webs of galaxies.
Yeah, or the great the great spider, cosmic web.
Cosmic web.
Yeah. And so our local group is just off from the Virgo supercluster. So one day we will join the Virgo supercluster or so, but not for a good couple of billion years at least. Fews of billion years at least. So, and this one was actually found in Parramatta in New South Wales by Scottish astronomer James Dunlop. So, and this was in June 30, 1826 as well. So, yeah, it's got some. You can see some.
It's interesting, Matt. There's other objects around in this field of view. I'm
Yeah.
not sure if it's on YouTube or not, but there's some faint, distant galaxies there. There's a clearly elliptical object happening down there, and I noticed down here there's a bit of extra detail there and over here. I've got no idea whether those are bits of interstellar medium in our galaxy or whether they're distant other galaxies.
Okay.
But, yeah, interesting.
Mel's is saying we missed out on. They missed out on exactly what the name of this object is because of the freeze. So it's called NGC 6744. So it doesn't have a nice name. It's in
the cluster of Parvo though.
Yeah. So I'll show it to you guys. You might not have seen it because of where it is in the night sky because of the open broadcast software freezing. So let me
Matt, while you do that, I'm going to flip over and get to the Grus Quartet.
Okay, cool.
And then I think I'll finish up after the Grus Quartet with a quick look at the Small Magellanic Cloud, which is rising up.
Yeah, no problem. All right, guys. So here in the southern, we're looking directly in the south here. So smack bang right in the middle of the sky, we've got the Pavo, which is the peacock, and it was noted by Josh earlier in the Discord chat about the Pavo star cluster that looks like a fireworks, and right near close to this galaxy is the Pavo globular cluster as well. So that little faint galaxy that we saw off in the distance there, that could possibly have been IC 4820 as well. So we haven't got around to naming these objects.
There are a lot of them. There's millions of galaxies out there.
Yeah, no problem, Mills.
Right, so let's see whether we're lucky with this or not. I haven't actually tried, I don't recall photographing these galaxies as a group before. I've got them individually. So it's going to be interesting to see what turns up in about 70 seconds on our screen.
Okay. We're waiting.
I'm impressed, Matt, that we've landed up with clear sky.
I know, and for so long as well.
Yeah. It's the best chunk of clear sky I've seen on my site for about three or 4 days.
Yes, yeah. And it's been quite wet. We both of us were actually going to be on the night sky tour on Sunday, and unfortunately, a storm front wanted to go through, so we had to cancel on Sunday. So
I presume we've got night sky tours back this coming weekend.
yeah, we do. Yep. So if you guys do want to come on our night sky tours, we're fully booked up to August, but we still have dates. Well, actually, we're up to now mid-September, but we still have dates in September, so you can book through the website perthobservatory.com.au. Fluffy Duck 19 said, I'm in the hills, so can I go out and outside and see some of these clusters, or is it too cloudy? Well, the last time I checked, which was just before the feed, the live stream, it was too cloudy. You can actually just make out the jewel box, right, which is right next to Beta Crucis, which I'll show you. So where we're looking.
While you're explaining that, Matt, I'll just jump in. I think that we've got cloud on the eastern horizon here, which is blocking. So I'm going to move on to see if I can get the LMC or not.
Okay, no problem. All right, so just right here, that's where the jewel box is, and that's a really nice star cluster. I think we'll try and do that next in the next fortnight, because I don't think we did it. We've done it for a couple of weeks now, and that can be the last salute before it gets a little bit too as low as well. So where we're moving on to
small Magellan Cloud. Sorry, I keep
So this is the small here. So this is one of the dwarf galaxies and you can actually see this in the actually you can just make it out here at the observatory with the light pollution, and this is one of the dwarf galaxies that exists around our galaxy. This one's about 250,000 light years away from us. There's also the large, which is a little bit closer. That's 160,000 light years away from us, and the actual small's gone through the large, and there's actually a magnetic bridge between the two. So where you can see down here the Tarantula Nebula, so it's slightly in the trees here at the observatory, but there's an actual magnetic bridge where they actually share stars, dust and gas, because the small went through the large and disturbed it. So they think beforehand the small Magellated Cloud might have been a small, very small spiral galaxy, where the large, if I remove the go through and just make it zero horizon, so the large, and I'll take away this. There you go.
Looks like I've probably got cloud in the south again here,
as
Matt,
well.
So might have run out of luck.
Yeah. All right. So we're coming up to 8:30. So what we'll do is we'll end the live stream there. Thanks, guys, for joining, and thanks for staying around. Hopefully you've had a nice night, and thanks for staying with us after the little error there with Open Broadcast Software. If you enjoyed yourself and you want to see this again, we'll be doing it in a fortnight on Wednesday at 7:30, and hopefully we'll be able to show some more stuff. And
in the meantime, don't forget about the Wide Field Milky Way workshop we've got coming up Monday and Tuesday. Not this coming Monday and Tuesday, but the next, so the 24th and 25th. And we'll be up at Kalbarri on the 20th of September.
Yeah. So guys, you can check out our Facebook page and also our website for all these events. We'll try and get this up at least by the end of the week for the Kalbarri night. I've just got to talk to the people up there just to confirm that we are coming up. Please, if you like this, please send it to your friends and family. Subscribe so that we can get more viewers, and we can hopefully monetize this live stream so we can do more of these and help also bring in some money for the observatory, because it is volunteer run. So it's got an amazing history. It's over 120 years. We're going to celebrate 125 years next year. So And Roger, we are planning another open day, not the 2016 open day, but
that was the biggest open day I've ever seen.
Yeah, we 2,500 people. So
yeah,
no problem.
That was big. That was when I stopped managing them. I thought, no, this is too successful for me to handle.
No problem. And yeah, oh, that's a nice one. Before we finish, what was that?
That's the spare tire nebula.
Ah, yes, the spec.
It's a little planetary nebula, but it doesn't suit this scope, unfortunately. It suits my bigger scope, but not this one.
Maybe we'll do the bigger scope next time you're on this.
Yeah, we'll do that.
Okay, cool. All right, guys, thanks very much for joining us, and we'll see you in a fortnight. See ya. Bye.
Later, everyone.